Page 36. This is where we start with angle measure. So you see here we have three learning targets. We're going to define angle, we're going to construct a copy of an angle, and we're going to construct an angle bisector. Okay? So, first, let's work on this definition of an angle. Before we can define angle, we have to define some other things. Now, these other things are not learning targets. These are words, terms, definitions you need to know. Okay? So, a ray is a part of a line. It has one end point and extends indefinitely in one direction. Rays are named by stating the end point first. Now, that's important because when we were naming lines or segments, it didn't matter what order we put the points in, did it? But with a ray, it does. Rays are named by stating the end point first and then any other point on the ray. So, this ray they show us over here, its end point is M. And it goes through point O, it goes through point P, and it keeps going. So we can call this ray MO or ray MP. Two different names naming the exact same ray, ray MO or ray MP. The symbol, when you don't write the word ray out, the symbol looks like a ray. It's an MO, and then the symbol above it has an arrow at one end. Now, sometimes people try to get too fancy with this. And if they have a ray that's pointing to the left, they'll try to make their symbol point to the left. No. The symbol always go to the right. We're not trying to say which direction the ray is moving when we write its name. Okay? End point first. I wish they called it the start point, because that would actually be a more accurate description of what it is. The start point first, then any other point that the ray goes through. Okay? Direction doesn't matter. You always use that symbol. So, start point first, any other point the ray goes through. All right? Now, opposite rays are two rays. Well, let's just read what the book says. If you choose a point on a line, that point determines exactly two rays called opposite rays. Opposite rays share a common endpoint, and they are collinear. Here's the way I like to think of it. Opposite rays, one, have the same endpoint. Two, they are collinear. And three, where the name actually comes from, they go in opposite directions. And all three things have to happen. Okay? Just because two rays are going in opposite directions does not mean they're opposite rays. They must also have the same endpoint. Just because two rays have the same endpoint does not mean they're opposite rays. They have to be going in opposite directions. Just because two rays are collinear does not mean that they're opposite rays. They also have to have the same endpoint and be going in opposite directions. Right. The one they want you to see is they want you to see ray JK and ray JH are opposite rays. But, yeah, K can go, you can make that ray, and that ray is opposite rays. Now, we wouldn't really know what to name that one, but, yeah, you're right. Any point on a line can be the end point. And sometimes we'll say things like a ray is half of a line. Well, no, it's not, because a line is infinite. You can't half infinity. When you take calculus, that's something we'll deal with, is we'll try to divide infinity by constants. and we'll decide that no matter how big that constant is, infinity divided by a constant is still infinity. Okay? So you can't cut infinity in half. So rays are not half of a line, they're part of a line. All right, we good with rays and opposite rays? An angle. So here's your learning target. In blue, an angle is formed by two non-collinear rays that have a common endpoint. An angle is formed by two non-collinear rays that have a common endpoint. Now, when we draw angles, we don't always draw the little arrows on the ends of the sides indicating that they are rays. And I'm not going to make you either. But you need to know that technically speaking, angles are made up of rays. In other words, the sides of the angles don't actually end just because we stop drawing them. They keep going on. All right? Now, some books do not include the word non-collinear. We'll get to that in a minute. But our book does, and so I will too. So that's what I expect you to know, is what I have there in blue. Now, the rays are the sides of the angle, and that common endpoint is called the vertex of the angle. So, ray xz is one side of the angle, ray xy is the other side of the angle, and point z is the vertex of the angle. Point z. Point x is the vertex of the angle. Okay? Now, naming an angle can get a little bit complicated. There are several different names we can have for this angle right here. Look at the ones the book lists. We can call it angle x. In other words, we can simply name the angle after its vertex. Look at the symbol for angle. You can write the word angle, x, or use that little angle symbol, x. All right. The other method is this. Name your angle with 3 points, but the order of the points matters. The vertex has to be in the middle. So it goes this way. You pick a point that's on one side, write it down. Then you pick the vertex, write it down. Then you pick a point that's on the other side and write it down. Okay? You must put the vertex in the middle. Now, naming an angle that is actually a pretty good way. It's a little bit cumbersome to write because, I mean, who wouldn't rather just write angle x as opposed to angle yxz, where we all would like to save that time. But it makes you trace out the angle with your eyes. If I say, hey, look at angle yxz, don't you look at y and then x and then z, and you're kind of tracing it out? So that's a good way. Now, you can reverse that order. You can call it angle zxy, but again, what's in the middle? The vertex. Okay? Now, my favorite way is the last way. Put a number in the interior of the angle. We'll talk about interior more here in just a second. And then name the angle that. So that little 3 right there doesn't mean 3 degrees or anything like that. It just means, hey, we're calling this one angle 3. Like having a uniform number. All right? It's angle 3. That's my favorite way because it's shortest and you can almost always name an angle that way. And I say almost always because you can't, well, let me show you this. If I make this kind of a thing, and I say that the vertex of that right there, that point right there is x. Then I say, all right, everybody, take a look at angle x. Do you have a clue which angle I'm talking about? No, because maybe angle x is this one, right? Or it could be this one or this one. Or look, it could even be combinations of these, couldn't it? Couldn't it be that one you can't tell. So naming an angle after its vertex doesn't always work. Calling something angle X when you have a drawing like this is counterproductive because nobody really knows if we're all talking about the same angle. Okay? Now, if you put numbers in here, that helps, right? 1, 2, 3, 4, 5, 6. I say, all right, everybody, look at angle 6. We all know which angle I'm talking about. Look at angle 3. We all know which angle I'm talking about. So that's good. But what if this was the angle that I wanted? Well, we don't have a name for that. So, naming angles after their vertex or a number is nice and convenient, and when it works, go ahead. But it doesn't always work. So what would we do? Well, we've got to pick a point off each, oops, that'd be bad, off each side. And if I say, all right, everybody, look at angle AXF. Do you know which angle I'm talking about? Angle BXD. Do you know which angle I'm talking about? Now, according to our definition of angle, angle BXE, see BXE, isn't an angle. According to lots of definitions where they take the word non-collinear out, angle BXE is called a straight angle. And I kind of like that. I like to have the ability of calling that a straight angle. So sometime later on in the book, we'll kind of shift our definition and include that. Right now, we'll stick with the non-collinear rays. But keep in mind that a lot of books will call angle BXE an angle. Okay? All right. Now, I talked about interior. That's one of these things that's easier to understand than it is to explain. If this is your angle, the region that makes up how to explain this? Probably the way the book does with examples, but I'm trying to come up with an explanation. The interior of an angle is the region of space that's within the shortest, no, that's not a good way, that's within the two rays. Now you might say within, we all mean here, don't we? So then that's the exterior out here. But I'm not comfortable with saying it that way because what I mean is, see here I'm wanting to divide infinity up and I can't. I'm wanting to say the smaller region of space is the interior, the larger region of space is the exterior, but both regions of space are actually infinite, aren't they? Don't they go on forever? So, see, I want to say that. You would understand it if I said that. I wouldn't be technically correct. So even though I said it and it's on the recording, and if you would send me your emails and I would send you the link, you could see this recording on iTunes U. You really could. It's there. It looks nice. Okay? Even though it's on the recording, I didn't really say that, did I? Okay. So I guess maybe the book's way is better. Points S and R are in the interior. Points O and P are in the exterior. And then the other choice is on the angle. N is on the angle. M is on the angle. Q is on the angle. Okay? All right. This is from your assignment on page 41. We're supposed to use the figure. It says at the right. I put mine above here. We've got to be able to communicate with each other. So we've got to understand these parts. I hope questions like these are almost so easy that they insult your intelligence. They may not. But we've got to be able to communicate with each other. So it says name the vertex of angle 4. So trace out angle 4. Don't literally do it on your book. Do it with your eyes. Which point is the vertex of that angle? U. Number 2. name the sides of angle 3. So again, trace out the sides of angle 3. Remember, sides are rays. Rays have a starting point. So this side right here should be called ray what? XW. We didn't start at U, we started at X. And then the other side of angle 3, what should it be called? Ray XU. And those are the names you have to use. You can't reverse the order of the letters. Now, you could have written ray XU first and ray XW second, but it's got to be those two rays. What's another name for angle 2? Well, look, here's angle 2. All right, another name for it, another good name. I could call it angle Y, but when we really know which angle Y is, no. What's another name? Okay. Because there's the 2. They'll always put the number in the interior of the angle. JR? Exactly. All right. Angle X, Y, U. Could he have called it angle UYX? Yeah. Yep. All right. And last, another name for angle UXY. All right, so starts at U, goes X, then through Y. So that's the one we're talking about. What's another name for that? Angle 1 will work. Angle YXU will work. There's even another one if you wanted to. I wouldn't want to go angle X, because that could be angle X, or that, or that, or that, or those two together. So I'd rather not call it angle X. Anybody see another one that you could call it? How about this? What if I called it angle ZXU? It's the same angle, isn't it? Or UXZ. Okay. All right, so far so good? All right, we all have a protractor. Your protractor is measured in degrees. Now, 1 degree is 1/360th of a turn around a circle. I have this nagging feeling that I used to know how come a circle was 360 degrees. I mean, they could, whoever made up degrees could have made them however they wanted. It would have been nice if they'd have made them like 400 degrees. Would be, a little better number to work with. But like I say, I have this nagging feeling I used to know why it's 360, but I don't remember anymore. Okay? So it's 1/360th of a turn around a circle. All right, now, I think you already know how to use a protractor. The biggest thing is you got to make sure that when you're measuring an angle, you line up the 0 on the protractor with one of the sides of the angle. Most protractors are like the one shown here on the screen, where that is the bottom of your protractor, but that's not where you need to line up the angle. All right, on most, some of them actually do put 0 right there at the bottom. I kind of wish they all did. But on most of them, see how you've got a 0 right there? One of your sides then needs to line up there. So you line up that side so that it goes through the 0, and then you read the degree measure as to where the other side of the angle goes through. Okay? And remember how this too. Every protractor has a 0 on each end, don't they? All right, this one has a 0 right here, and it has a 0 right here. So if I had a different angle, like that, I could measure it that way. So, how you put your protractor down, just make it fit the angle. I don't care which zero you use. Just use one of them. And then you might ask, well, which do I use, the outside numbers or the inside numbers? It depends on where your zero was. If your zero's on the inside, then you're using the inside numbers, right? 10, 20, 30, 40, 50. That's a 50-degree angle. If you put your protractor down so that your zero's on the outside, then the red angle I drew in is 10, 20, 30, 40, 50, 60 degrees because I'm using the outside number. Make sense? Okay. Classifying angles, you should already know this. Right angles have a measure of 90 degrees. Acute angles have a measure less than 90. And obtuse angles have a measure greater than 90. What we usually don't bother saying is that obtuse angles are greater than 90 but less than 180. That's not really going to come into play for us. Okay? But technically this definition is correct. They're greater than 90, they're less than 180. Notice I usually don't say the word degrees. We're just assuming that we're always measuring angles in degrees. There are other ways to measure angles. When you get to calculus, we will use radians. In fact, in pre-cal, when you're doing trig, you'll use radians. But for us, it's always going to be degrees. We don't have to say it. We don't have to put the degree symbol because it's always going to be degrees. Now, in your science class, they probably expect you to put the degree symbol. I'd like for you to, but sometimes it kind of gets in the way. We've got jumbled up figures and whatnot, and sometimes, you know, if we're not careful, the degree symbol ends up looking like a zero, and it's not a zero, it's a degree symbol. So I'm okay with you leaving it off, all right? Because we're always measuring angles in degrees. Other thing I want to point out, that little symbol right there, they tell us it means 90 degrees. It also means right angle, because right angle and an angle whose measure are 90 degrees mean the same thing. And it also means, do you know what else? Perpendicular. We're going to use that one little symbol to mean 90 degrees, right angle, and perpendicular. Okay? Now, it'll take us a couple days to work through everything where the book tells us that those three terms mean essentially the same thing. All right? We'll learn that right angles are formed by perpendicular lines, or that perpendicular lines form right angles. But that little symbol means right angle, it means 90 degrees, it means perpendicular. All right, to number 5. It says copy the diagram shown, you don't have to copy it, and extend each ray and classify each angle as right, acute, or obtuse. Then use a protractor to measure the angle to the nearest degree. If you've got a small enough protractor, you can lay it over the figure in the book and measure them. If you do not, and most of you do not, most of you, your protractor dwarfs that little drawing in the book, doesn't it? And so you can't really use it to measure. That's okay. We can still classify these. So let's classify them first, then we'll worry about their angle measure. So, number 5, angle CFD. Starts at C, the vertex is F, then to D. That's fairly obviously an acute angle. Number 6, angle AFD. Starts at A, goes to F, then to D. That one's obtuse. Angle BFC. That's right. Hey, I can get that one. That one's 90 degrees. And last, angle AFB. AFB. Back to acute. Now, as far as getting their measures, let's just estimate, okay? For the first one, it was angle CFD. I don't know, what do you think? 40-ish? 45? 50? So I'll take any of those, okay? Book says 40. All right, number 6, angle AFD was this one. All right, we know it's bigger than 90. In fact, it's getting fairly close to being, as big as an obtuse angle can get. What would you guess? 150, 160, 130? I'll take any of those. The book says 150. We knew what the measure of right angle was. AFB, that one's fairly narrow, so 35, 20, 25. It's fairly obviously less than 45, right? Because perpendicular to that would be something like that. Looks like less. So probably something less than 45, bigger than 2. Book says 25. So don't worry about getting exact answers with your protractor. That's not the point. Because I don't want, it says copy that. Well, if you copy that, it's not going to be exactly the same way as it was in the book anyway. So I'm not all too worried about that. All right? Congruent angles. Just as segments that have the same measure are congruent segments, angles that have the same measure are congruent angles. And the way we mark those on a figure is with a little arc. So notice in the figure that this angle is 65 degrees and this one is 65 degrees. So put one little arc in the interior of each angle, that marks them congruent. Then look at those two angles that have two arcs. They don't tell us the measure, but guess what the two arcs mean? Those two angles are congruent. Okay? So, if you're told that two angles are congruent, you conclude they have equal measures. If you're told that two angles have equal measures, you conclude the angles are congruent. In symbols, the way you write measure of an angle is with an M for measure. So if I write the measure of angle ABC, then I'm really talking about a number, aren't I? Because measures are numbers. So the measure of angle ABC and angle ABC are not the same thing. In the same way that segment XY and the length of segment Y are not the same thing. One of them was talking about the number, one of them was talking about the segment. In this, the one with the M, meaning measure, is talking about the number. The other one is talking about the actual physical angle. You think you got it? I think you got it. And that seems like a pretty good place to stop.